This is also a good way just at the beginning of the year to get students feeling safe about making guesses and speculations, because I couldn't expect to know what's inside here. Okay, so I have to explain this stuff.
She has 4，
然后再再拉上，所以总共有几条？1、2、3、4、4。Yes, that's right.
Somebody else. Another idea. Does everyone agree with this?
告诉你的想法，跟刚才这位伙伴的想法不一样的。对，再一个这边。
Would it help if I did something else with this? Other than opening it or opening it?
它不会开的。
Tell me what to do.
但是你有没有想要再做进一步的观察？然后告诉他希望做什么操作，然后你要想进一步的观察，这样帮助你思考。有点察觉啊。
Now we can touch it. We're trying to figure out what's inside, so we're manipulating.
对啊，也许如果想要真正拉一拉那种感觉哈，有的人是要去真正的操作，可以去想。没有人想要再亲自操作看看。
We did this in Changhua.
对，他在台湾其实有好几个地方
With
操作
middle
过这
school
个，
students, they
根
came
本大
up
家
with
都没有参加过，还好。
six different answers.
他之前在彰化的时候有跟在场的伙伴弄出了6种不同的解法。
Another possibility?
所以我们只有1个而已哦，赶快大家再发挥一下，我们要创意没？是吧？
Go draw something up here. He's thinking about it, but that's okay. I'm never going to open this up, so I'm not going to show you what's in there, so it's safe.
所以没有答案 ，OK？ 所以大家可以自己找出自己答案。
Okay, next circle, what's in circle?
现在3分钟，那个圈圈。哦，好了，好了怎么样？可以帮忙好了。
A bully.
哦 ，OK。
So how many strings does he have? 3? Okay. Okay, I need one more now. Someone else has something different. people agree with this?
有多少人同意？
4, 5, 6. Okay. How many agree with this? 1. Nobody likes that. Okay, that's only 7 people.
还有呢？所以只有7个人举手，那表示其他还有其他的设计，或者是其他的那个答案。所以没有举手的，请来上来画。
Is it the lunch they tired? You can draw one, go ahead.
Well, I would like to try it.
Get your professor to do it. Oh, he's gonna see. That's absolutely. So what's he trying to find out?
Find out the one. Circle. There is a circle.
Another pull here.
Yeah, recording. And
Okay, so that's three screens also.
yes.
Okay. How many agree with your professor?
Oh yeah. Good.
We love you.
Okay, but that's something else that happens in science, that people will agree with famous people on the people they don't know, and they disregard the information. Okay, so how do we find out which of these 3 is correct? Who's right?
接下来我们要怎么去确定哪一个是对的？
Now, I'm not going to open it, because I'm going to say I'm unable to open it, because it's just like a lot of things in science where you can't open up the universe and find out. So, in a geology book, oh, is that one?
Yeah.
Oh, another professor. Will they to agree? He's the engineer here.
Yes.
Engineer.
Yes.
If he takes his glasses off, he can. Here we go. So you have 2 strings. This only has 2. So you have 4, 3, and 2. And what's this in here?
Also part, right? It's a part. Right. Part.
Yeah,
Okay.
okay. It is a string with love, right? It's a
Is that 2 strings? strings up? Just two strings. Okay. How many agree with that one? No way.
哦，你们
He has to agree with it.
没有人要同意这个，OK。
Okay. So, like I was saying before, if you look in an earth science book, there's usually a picture of the earth, and they show you what's in the center of the earth, and all the different layers. If you look in a general science book, there'll be a picture of an atom, and no one has ever seen that. And no one has ever been to the center of the earth. But there are pictures in science books about these things. So this is similar to the atom, or the center of the earth. So I can't open it up to look inside. Not yet. Maybe with technology, someday we'll be able to actually see what's in the center of the earth. And maybe we'll have electron microscopes strong enough to see an atom. But right now we do not. But we have an idea of what we think they look like, because we make certain observations and then we figure out what's inside. There's one next step that scientists would now do to find out, gee, I have 4 different ideas about what's inside. How can I find out some more information?
Motion test.
Hmm?
Motion test.
Okay, what's that?
Just
Do more things, okay. So I can collect more data, pull various things that I didn't do before. Maybe I'll do
Yes.
that. Okay. Okay, so I make more data, and then he may have just changed his mind. And that happens in science also. That's why all scientific knowledge we say is tentative and it's subject to change. Okay? You made some observations, and then you inferred what's inside. I got you to ask some questions just by holding this up. You started asking about what's inside. You changed?
Just well, time together.
Okay.
Just what do you want? Type? None.
Modify again.
Okay, so what they're doing, what's happening now is, they collected more data, but now they're responding to each other's. If someone poses an idea, oh, I never thought about that, and now he has another idea. What's that circle? What's this?
不一定要把
是拿不一定是拿玻璃，然后就是
So he just says,
something with
Okay, so this has a ring, this has a knot. Okay, 2 strings, some have 3, some have 4. Again, how can we find out which of these people is right? I can't open it up. What do we do? Okay, so how do we test these models? And this is like a theoretical model of what's inside. How do we test that? What you can do with a class is let students now make their models. So I can have a bunch of tubes that I get from the center of toilet paper rolls, these smaller tubes. This is a tube that I just got from the library that mails charts and things and maps. Okay. You could take paper towels, they have a tube in them. So it's easy to get the materials, or you can send the students home to have them make their model. So you come back to class the next day, and I have at least these 6 different models. And now you set yours up like this, and you do the same thing I do, and you see if your model works like mine. And that's one of the ways in science that we test out our inferences. And when they're the type of inferences we can't actually look at, we make something that has an inference that you made and see if it works like mine. What if your model doesn't work like mine? What does that mean? You make this, okay, let's say you made this, and when you try to copy what I do, it doesn't work. What does that mean? It means this model is wrong. Okay, it doesn't work like mine. Okay. What if your model works just like mine? What does that mean?
Function. The same function.
Because she said, okay, maybe, but you tried it. And sometimes in science, a lot of it's trial and error. And let's try this and try that. Okay? But that may take a lot longer if you just guessing. But if it does work, like mine, what does that tell you? Does it tell you what's inside mine? Only one person responded. I won't say what he said. Okay,
Yeah.
so if it works like mine, it may be like mine, but it may not. Maybe there are different ways of creating this effect. And so scientists all the time make inferences from data, and sometimes there are more than one inference that can be made. And then we can make predictions. Well, what if I do this and they may still work? And this is why in science we have competing ideas about how things work. For a long time, there was a lot of debate about what the center of the Earth was made of. Was it a liquid? Was it a solid? Was it made of iron? Or whatever? The picture in your textbook of an atom doesn't look like what we currently believe. They had that solar system. Right? In textbook, they have this nucleus, and they have rings of electrons around it. Looks like a solar system, which is not what we even believe anymore. But it's a good way to teach students about subatomic particles. What we currently believe is, rather than looking like that, we have a quantum mechanics version of what's inside an atom. Still nobody has seen it. But that comes from making observations of how atoms behave, what they are attracted to, what they're not attracted to, and so on. Okay. But the key question is, if yours looks like mine, you don't know for sure. You may change your mind like you did, and you did, when more information becomes available, and that's what you would use this for. There are different ideas about how to make a car. He works with car engines, right?
What?
He works with car engines and cars.
Yes.
Okay? And many people work all the time trying to develop more energy efficient engines. And all the engines don't look the same. And ideas change. So the same thing happens in technology. We have ideas about what's the best way to make a bridge, what's the best. You had a project where you were building a building, right? Which is the best model for a building that met the criteria that you were asked to address? Okay. One of those looks exactly like what's in here. But I'm not going to tell you which one. Okay. And sometimes people put these up, and none of them look like what's inside here. But I was talking about the the middle school students in Changhua a couple of years ago. They had 6 different ways of making this. And each of the 6 worked like mine. But none of them was what I had here. And that happens in science all the time. We never really know anything absolutely, but we come to explanations, and as long as they allow us to predict how things will behave, we stick with those ideas. Getting back to engineering, I was showing this to a group of engineers at a university I used to work at. And none of the things they came up with was what I had in here. So I went to the board and I said, well, could it look like this? And I drew what's inside here. I didn't tell them that's what it was. And one of the engineers says, that's impossible because nobody would make it that way. Can you translate that?
他刚刚在讲这个东西，应该一部分知道，他是在他的学校，那一群都是那个机械系，跟机械有关的那个学生，然后他们设计出来的都跟他的不一样，然后他后来画了一个，是几乎是他里面的那个样子啊，但是那些那个机械系的学生不相信，他们认为不可能操作出来是那个样子，有时候大家对这件事情的认知是有不同的。
Okay. So sometimes we can make things that are much more efficient and much simpler than the way it is in nature. And engineers do that a lot. Sometimes the things we make are much more complicated than the way it actually works in nature. But again, engineers and people that work in technology are trying to produce a tube that works like mine. Science people have different types of questions. They're asking, what can explain the way this thing works? And there are several ways to explain what things work. When I use this in the class, I usually use it before I talk about the model of the atom. Because I have to teach about the atom when I'm teaching biology. I don't have to teach about the center of the Earth, so I don't use it for that, but you could use it for that as well. But this is an analogy to the way science works and how to do research. I could illustrate inquiry with this. What did we do? Well, I pulled that string because I wanted to see what effect it had on something else. And you could then talk about what I was talking about earlier about what's your question? What design or data would you collect? If we all do the same thing, we get the same results, and so on. And you can talk about all those things. And it doesn't take a long time. People often think when you teach about inquiry, the nature of science, that you don't have time to do that. It really takes not that much more time than teaching content without that. And students will understand the content better. They understand no one's ever seen an atom. They have a better understanding of an atom than if they think it looks like that picture. And this I never open up in front of a class of people. I've had students 10 years later write me email trying to figure out what's inside. And sometimes you can open it up, but most of the time in science, you can't open it up. Sometimes it's a piece of technology that would allow us to actually see what's inside, and that's fine. But that's equivalent to opening these things up. Okay, so I can tell you, I actually don't, but I'll tell you. This is actually right.
That's right.
What's inside here is, oh, I opened it up. A ruler of the universe is a little plastic ring. Both ropes go through the plastic ring. And there's one rope across the top and one across the bottom. Now, I could have made it, I was teaching a class. I could have had this string go this way, and this string go this way. So different than his, where this is the other end of this ring. In mine, this would be the other end of this, and it worked the same way. You don't even need to put a ring in there. The ropes would just go over each other. But some students will feel if there's any friction, well, there's more friction when there's no ring. Okay, so that's something you can use to teach about observation, inference, and how we construct models in science. And engineers also think about, because engineers always think about making things in the most efficient, best way. And how they would make something doesn't necessarily match up with how it occurs in nature. Okay, so there's a difference if you're teaching in an engineering kind of class versus a science class. Okay. Just some, these are, what grade are these, Judy?
They're first graders.
These are first grade.
First. They're 6 years old.
一年级，他有那个主编是一年级的小朋友。
There's one.
We asked them to write down the number of strings. So she wrote it backwards. But she had 3 strings.
Okay, and that looked like, we didn't have that model here.
And he did 4 strings.
This is one with the knot in the center.
He did a ring
Similar
and
to
so
this
like
one,
the
maybe.
ring and 2 strings.
Okay, so this guy or gal has a little man inside. Okay, so when that happens, students do funny things just to mess up the lesson. And if you show that in your class, your other students will laugh just like you laugh. And why did you laugh? Why was this funny? I think it's funny. But why is it funny? Have we ever seen a little person like that? Probably not. Did you have any data to say there's a little man inside of you? Okay. So this inference is one that would be beyond the bounds of what scientists, or you as scientists, would permit as an acceptable explanation. And you hear that all the time. Scientists say, they argue on TV some of these pseudoscience things where they make claims that don't fit with what we know and the data. That last item on the knowledge about inquiry was that our explanations and conclusions are a combination of the data collected and what we already know. We might find out 20 years from now that there are little people that are this small, and it could be right. We've had that happen in science all the time, where when we're looking at Earth and plate tectonics, the first person, Wegener, who decided that the continents actually move, the scientific community laughed at him. And then 30, 40 years later, his idea was the correct idea. So in science, we often, it's when we think we have the best explanation. We reject the ones that are so different than what we possibly would believe. And usually that works, but every so often, that very crazy explanation is the one that everybody now suddenly understands to be the correct explanation. So if you stress with your students, and you do it in any inquiry approach, that they should draw conclusions based on the data they collected. And the conclusions should always be based on that data, and they should feel confident as long as they can explain what's going on with the data they have. And that's what we do in science all the time. So that's what we use that tube for. And that tube, I think, I think that was the last